All right, Algebra 2 students, let's review sections 5 through 8. I provided you with a worksheet online, and I'm going to work through those problems now for you. Here we go. First one says find the inverse if it exists. So number 1, remember the first step? To negative 1, 1, 0. The first step is to find the determinant, which is 2 times 0 minus negative 1 times 1, or 0 plus 1. So my determinant is 1, which is not equal to 0, therefore I can continue. So I take 1 times, I switch these, I change the signs of these. And 1 doesn't change anything, so my inverse is 0, 1, negative 1, 2. Number 2, same problem. So we have 4, 7, 3, 5. First I find the determinant. 20 minus 21 gives me a negative 1. Negative 1 is not equal to 0. So negative 1, I'm sorry, it's 1 over negative 1, which is the same thing. I switch the numbers. I change the signs of the numbers. Don't switch them and change the signs. Just do one or the other. Okay. So that makes negative 5, positive 7, 3, negative 4, final answer. Number 3 is the same thing. Here we go. 3, 4, 3, 4. The determinant is 12 minus 12, or 0. So no inverse. Good job. All right. Number 4 says find the determinant. Negative 3, 4, 1, negative 1. Again, we multiply. Negative 3 times negative 1 minus 4 times 1. Negative 3 times negative 1 is 3. Minus 4 times 1 is 4. 3 minus 4 is negative 1. Number 5. We'll go to the next page for the last one here. 3, 9, 3, 2. Again, find the determinant. That's 6 minus 27. 6 minus 27 is a negative, 21. Bad brain there. Negative 21 is correct. Okay, moving on. Number 6 is a 3 by 3. Again, we're finding the determinant. So negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, negative 4. Again, recopy. I'm going to use a different color here. I'm going to recopy these first 2 lines. Negative 3, negative 2, 0, 1, and 3, 4. And then I'm going to multiply. So these going this way, I'm going to do, and then I will do the others going this way. Okay, so negative 3 times 1 times negative 4 is 12. 2 times 2 times 3 is 4 times 3, which is 12, and it's minus 12 because there's a negative sign there, and that's a 0. Going the other way, that one's a 0. 2 times 4 is 8. 8 times 3 is 24, so it's minus negative 24. And 1 times 3 times 1 is 3 minus negative 3. Those make a 0. That makes a plus, so I have 24 plus 3. I have 27 as my determinant. Okay, number 7 says solve. We have negative 2, 3, negative 4, 5. We're looking for matrix X, and we have 6, 8 over here. So first we need to find the inverse of this. So can we? So negative 2 times 5 minus 3 times negative 4. Negative 2 times 5 is negative 10. 3 times 4 is 12. Negative is a positive. So I end up with 2. Yes, I can. So 1 over 2, switch, change the signs. Multiply that out. So I get 5 over 2, negative 3 over 2, 2, and negative 1. Bring this guy down, and we multiply. 5 over 2 times 6 is 30 over 2. Negative 3 times 8 is negative 24 over 2. Leaves me 6 over 2, or 3. And 2 times 6 is 12, minus 8 leaves me 4. So my final solution for matrix X is 3, 4. Okay, I believe we're ready for number 8. Again, we're solving, so we have 1, 1, 1, negative 1 times some unknown matrix. 3, negative 1 is our solution. Again, we have to find the determinant, so negative 1 minus 1 is negative 2. So we're 1 over negative 2. Switch, change the signs. Okay, we multiply that out, gives us 1 over 2, 1 over 2, 1 over 2, negative 1 over 2. We multiply that, 3, negative 1, and we get 3 over 2 minus 1 over 2, and we get 3 over 2 plus 1 over 2. Well, 3 over 2 minus 1 over 2 is 2 over 2, or 1. And 3 over 2 plus 1 over 2 is 4 over 2, or 2. So our X has a value of 1, 2. All right, that takes care of page 1. Let's go to page 2. It says, write a system and then solve it. Okay, well that's not as hard as it sounds. So writing a system just means write it as a, I'm going to use Cramer's rule if that's okay with you. I get 6, 9, 4, 13. I solve that. So that 6 times 13 is 78. And minus 36 gives me 42. So I have 1 over 42. Oh, this is using an inverse. I don't really want to do an inverse. Let's do, it doesn't say how. So, yeah, I guess I can do both. So as the inverse, it's 1 over 42. 13, negative 9, negative 4, 6. That leaves me the inverse of 13 over 42, negative 9 over 42, negative 4 over 42, and 6 over 42. I multiply that by 36, 2. Those are my answers. Okay, which gives me, oh, this is messy, 468 over 42 minus 18 over 42, and negative 144 over 42 plus 12 over 42, which gives me 450 over 42 and negative 132 over 42, for a total of 75 over 7, negative 22 over 7. That was an ugly problem. There it is. All right. I could use determinants. It doesn't matter. It all works out the same. It's whatever you choose to do. That would be fine. All right, number 10, I do want to use a determinant because I don't want to do craziness like this. I could have done, yeah. So I guess number 10 is going to be the same as 11, 12, and 13, but let's do 10 here really quick. We have 1, negative 1, 1, 1, 0, 3, and 0, 1, negative 2. So I find the determinant of that by copying. So that would be a 0, that would be a 0, that would be a 1. So I have 0 plus 1. And this way going back, I have minus 2, minus 3, minus 0. So 1, that's negative 5, so negative 4. So I find the determinant with either the x's, the y's, or the z's taken care of. So I'm going to replace the x's because that will make it super easy. So 3, 6, negative 1, copy in again, negative 1, 0, 1, 1, 3, negative 2, copy over, and multiply. That's a 0, that's a plus 3, that's a plus 6. That's a minus 12, a minus 9, and a minus 0. That's a minus 21, and that's a positive 9, so it looks like negative 12. So negative 12 divided by negative 4 is 3. Since I know x is 3, and I have the equation x plus 3z equals 6, 3 plus 3z equals 6, so 3z is 3, z must be 1. If the z is 1 and x is 3, I can find y. Ooh, let's use this one. Minus 2z is negative 1. So y minus 2 is negative 1, so y must be 1. So I have x is 3, y is 1, z is 1. And there's my answers. That wasn't so terrible. That was number 10. All right, we have 3 more. Number 11, Cramer's rule, my favorite rule. So we start with the determinant, 3, 5, 1, 6. Multiply them out. 18 minus 5 is 13. Replace them. 1, 9, 5, 6. That's 6 minus 45, which is negative 39. Negative 39 over 13 is negative 3. So x is negative 3. And I can just plug it in. I have x plus 6y is 9. So negative 3 plus 6y is 9. So 6y is 12. Looks like y is 2. Here's my x. There's my y. Number 12. Negative 3, 4, 2, negative 8. Again, multiply them out. 24 minus 8 is 16. Replace them. Negative 8, 16, 4, negative 8. 8 times 8 is 64. And minus 64 is 0. That looks a little funny here. Hang on one second. Yep, it sure is. So 0 divided by 16 is still 0, so that is what x is. If x is 0, 3 times 0, sorry, negative 3 times 0 plus 4y is negative 8. That goes away, so 4y is negative 8. Y must be negative 2. Here's my x, here's my y. Last one, number 13. Again, I like Cramer's rule for the 3 by 3s especially. All right, so we have 3, 1, negative 2, 1, 5, 1, 1, 0, 3. Recopy. 3, 1, 1, 5, 1, 0, and multiply. 3 times 5 times 3 is 45. 1 times 1 times 1 is 1. 2 times 1 times 0 is 0. 1 times 1 times 3 is 3. That's a 0. 2 times 5 is 10, times 1, it's a minus, so it's a plus 10. So 45, 46, that takes it down to 43, so it's 53. Got it. All right, now we go to the next one. I want to replace r. So I'm going to put 22, 40 in here. 1, 5, 0, negative 2, 1, 3. Copy them over. All right, 22 times 5 is 110, times 3 is 330. That's a 0 and that's a 0. 1 times 4 times 3, that's a minus 12. That's a 0 and that's a 0. So 330 minus 12 is 318. So 318 divided by 53 is 6. And that's the only determinant I have to find because r plus 3t equals 0. So 6 plus 3t is 0. So 3t must be negative 6. So t must be negative 2. So far, so good. I have r. I have t. I need to find s. So I'm going to go back to the top one. 2 times r, or 3 times r, so that would be 18 plus s minus 2 times negative 2 is plus 4 is 22. S must be 0 because those add up to 22, and if I subtract that, I get 0. Okay, I know I went kind of fast. But you have lots of opportunities to replay the video as many times as you need to. I wish you luck. See you Friday.